For an object to orbit around a planet in a circle, it needs to reach a minimum orbital velocity. The orbital velocity of an object is the rate at which it is moving around a planet and how fast it would speed away from the planet if it wasn't being pulled down by gravity. When these two effects are in balance, the orbital velocity speeding the object away from the planet and the acceleration due to gravity pulling it towards the planet, then the satellite will maintain its position above the planet. Let's find the equation that represents this balance. After an instant in time, the orbital velocity of the satellite moves at a distance equal to v times t, or the orbital velocity times time. During the same instant of time, gravity has pulled it towards the center of the planet, a distance of 1/2 g times t squared, where g is the acceleration of gravity on the planet. If the satellite revolved around the planet and didn't change its position above it, then its distance from the center is the same, which we will call r. Now we have a right triangle, and we can use the Pythagorean Theorem to create an equation relating all these variables together. This gives us vt squared plus r squared equals the square of 1/2 gt squared plus r. If we square the binomial on the right side of the equation using FOIL, we get these terms. Now we have an r squared term on both sides of the equation, so we can cancel those terms out. We can also divide both sides of the equation by t squared to isolate velocity on one side of the equation. After that, we can take the square root of both sides of the equation to get an equation for the orbital velocity. Now this equation depends on time, but we want to know if this relationship holds true for even the most infinitesimal amount of time change, because the satellite is moving in a continuous curve, which means if we set time equal to a trillionth of a second, this equation would have to be true, which means we can set this time term equal to 0. This gives us the final equation for orbital velocity, which is the square root of the acceleration due to gravity times the distance the satellite is orbiting from the center of the planet.